Welcome to Dive in 5 for Grade 5, Multiplying Fractions and Mixed Numbers. My name is Barbara Knox.
And I'm Daryl Frost. Welcome.
This is your first task. We would like you to pause the video and either by yourself or with a team or partner, go ahead and solve this problem, either using a model, concrete tools, a picture.
Yeah, any of those would work.
Yeah. So looking at the progression of standards with their benchmarks within BEST, you can see that they've started their operations with fractions in 4th grade. We're going to continue that fraction operation with fractions and mixed numbers in 5th grade, but now we're not going to be limited to like denominators. They're going to be multiplying not just fractions by whole numbers, but fractions by fractions and fractions by mixed numbers times mixed numbers.
Yeah, and so area and perimeter, they already know a lot about area and perimeter, but now we're just talking about side lengths. That could be a mixed number or a fraction.
Everything that you see within that gold loop is going to be included in this unit. However, our Dive in 5 is going to be focusing on multiplying fractions and mixed numbers and the different models that you can use for multiplying. You can see included in this unit, you're going to be finding area of rectangles with fractional side lengths, and you'll also be working with that scaling benchmark, determining whether the product is going to be greater than, less than, or equal to the other factor.
So taking a look at this problem here, you probably have modeled potentially with fraction bars or Cuisenaire rods, or drew a picture of what Sydney started with. She has one whole yard and then 1/3 of another yard to show that 1 whole and 1/3 yards of ribbon. So
Yes.
She's beginning with that.
Because that's what we're starting with in the problem. That's what she has, and we're going to be finding 2/3 of what she has. So we are trying to find 2/3 of the entire length of ribbon. So I have to take that entire length of ribbon and separate it into 3 equal parts, right? So here's my 3 equal parts of the whole length of ribbon, not of 1 whole yard, but of the 1 1/3 yards. Of that, I need 2/3 of that ribbon, right? So I'm going to take 2/3 of that 1 1/3 yards.
That makes sense. I see that.
Okay.
Okay.
But when I'm naming my product is going to be a fraction of a yard, right? So I have to go back to the 1 yard, and what is that yellow part in relationship to 1 yard? What fraction of 1 yard is it?
It's, well, the 2 yellow pieces there, it's,
Does this help you?
Oh, okay. It's 9ths.
Right, so I'm going to break that into 9 equal parts.
Okay.
And this would be really easy to model with Cuisenaire rods, right?
And we had mentioned that,
yes.
Right?
So yeah. I know the colors don't match on our PowerPoint,
but thirds and ninths are relational.
Correct. So I can break that whole yard into 9 equal parts, and now I have 8 of those 9 equal parts is equal to those 2 yellow thirds from
Yes.
the thirds of the whole amount of ribbon.
Right. So then the product would be right here.
Yes, 8 ninths of 1 yard.
Yep,
You're
that's
correct.
exactly.
Another way that we can look at this is to use the distributive property. So if I'm taking 2/3 of 1 1/3, I can take 2/3 of the 1 yard, which is really easy to see, right? Because it's already divided into thirds.
Yes.
And then 2/3 of 1/3 of a yard. So first I'm going to look at the 2/3 of 1 yard, which I know is 2/3.
There you go. Yeah.
And then I'm going to take the 2/3 of 1/3. So I have to break that 1/3 into 3 equal parts. But I have to remember that that's only 1/3 of a yard. So those orange pieces are actually what fraction, Daryl?
Well, if that's 1/3 of a yard, then I'm going to need to duplicate that. Another third, so that'd be 9 pieces. That's going to be ninths.
So right there I have how many ninths?
3 ninths.
3 ninths, but the light
But
orange, the
light
2/3
are the part that I'm considering.
correct.
So it's going to be 2 ninths.
2 ninths right here and 2/3 right here. So
Yes.
in order to have, really I'm adding the 2/3 to the 2 ninths to get my total.
Yes. There you go.
So I have my 2/3 and my 2 ninths, which I know I can break that 2/3 into 6 ninths.
Rename
and
it.
add it to my 2 ninths to get my 8 ninths.
There you
go. Same product, 8 ninths,
Yes.
just a different model.
Yes, absolutely. Yeah. And it's interesting how you thought about the distributed property, because we do that with whole numbers. I can do that with
Correct.
mixed numbers as well.
So now we're going to look at using an area model. And with an area model, again, I'm going to model my 1 1/3, and you can see my 1 1/3 in the picture, correct? I have 1, and then I have 1/3 of another whole.
That could be the width,
right?
Or length.
So I'm going to break the whole into equal sized parts to match my thirds from the 1/3 that I see. So now I have 4/3, which is equivalent to the 1 1/3, right?
Yes.
But what I need to do is find 2/3 of that. So I'm going to, in the opposite direction, I'm going to split it into thirds, and I'm going to look at 2/3 of that. Right?
Yeah, I see that.
So I've broken it down again, and I can look at 2/3 of one whole plus the 2/3 of 1/3, or I can just look at the whole thing, 2/3 of my 1 1/3 as a whole.
Well, I'm looking at what the whole is, and I'm seeing 9 pieces to make the whole.
To make one whole.
To make one whole. So I know I'm thinking about ninths now, since I decomposed the 1 1/3 into 2/3.
Correct. And the overlapping segment, that purple segment, is 8 pieces.
8 pieces.
Again, I'm going to get the product of 8 ninths.
Yes. Yeah.
Just a different model.
Just a different model.
Yeah. We're going to take a look at one misconception that happens quite often when we're working with word problems with multiplication of fractions. And Daryl, we know, you and I know, that students often confuse two operations when it's
multiplication and subtraction.
Yes.
That ribbon problem, I could easily see students subtracting, and that if it was a multiple choice assessment, that would be one of the solutions.
It would be one of the distractors. Yes, it would.
Not a distractor.
So we are going to look at that problem again, and a very similar problem that is a subtraction word problem, so you can help your students see that difference. So here you see the problem we just completed on top. And I want you to read also the problem on the bottom. I'll give you just a minute to do that. Daryl, how are those two problems different?
Okay, well, at first glance, you look at them, you think, well, it's the same problem. I want to perform the same operation, but you have to really think about what's happening.
Yes.
In the first scenario, she used 2/3 of the ribbon to make a bow for a gift box.
And how much ribbon did she have?
She had 1 1/3 yards of ribbon. So she's using 2/3 of the 1 1/3 yards of ribbon.
Exactly.
That's like thinking about a part of a part. So I'm using multiplication there.
There's my multiplication problem.
The second problem is actually a subtraction scenario.
Yes, it is.
Because she's starting with the 1 1/3. She's using 2/3 yards of ribbon, so she's using 2/3 of 1 yard of ribbon.
And that's very different
That's
than
very
2/3
different.
of 1 1/3 yards.
Yes,
right?
it is. It's an action of where she's taking it away.
She's cutting parts of that 1
1/3
off. She's
yes.
cutting 2/3 of a yard off from that 1 1/3
yes.
Yes. So you can see the words are almost identical until you get to the question. And the thing that makes it different is I'm taking 2/3 of the entire thing, or I'm taking 2/3 of one yard. So here again, we have two very similar problems. The context is almost identical. Cameron is eating cake. I want you to take just a few minutes as an audience and think about which of these problems is modeling multiplication and which of these problems would be modeling subtraction.
Well, if I'm thinking, and I'm sure whoever is participating in this video, the first scenario, it would be a multiplication problem.
I don't think so, Daryl.
You don't think so? Well,
he's eating 1/4 of a whole cake.
Okay, he eats, and there was 3/8 of a cake in the pan before Cameron started eating. So if there was 3/8 there, and he ate 1/4
of the whole cake. So we're taking 1/4 away from the 3/8 to see how much is left in the pan now.
So that's subtraction because he's eating 1/4 of what was left.
He's not eating 1/4 of what was left. He's eating 1/4 of a full cake.
Oh, he's eating, okay.
There was 3/8 of a cake left, so before he started eating.
But it's relational to the whole.
They're both relational to the whole. So that first one is subtraction. Our second one is the multiplication problem, because in that second problem, he's eating 1/4 of the leftover cake. And we know that 3/8 of the cake is left over. So here he's eating, in the second one, he's eating 1/4 of the 3/8, where in the top one, he's eating 1/4 of a whole cake.
Okay.
So the difference is, what am I eating? Am I eating a fraction of the whole amount that's left, or am I eating a fraction of the whole that's represented, in this case, a whole cake?
Okay. So because in the first scenario, it's 1/4 of a whole cake, it's takeaway.
It is subtraction. Because I'm trying to find the difference between what Cameron ate and what was in the pan before he started eating.
Students need experiences with just determining the operation.
So my recommendation to you as a teacher is, whatever problem you're giving them, both with subtraction and with multiplication, try to present two problems that are very similar like this, where one is subtraction and the other one is multiplication, to give them the exposure to the differences in how I solve each of those problems.
Definitely.
Thank you for joining us for this edition of Math Dive in About 5 on multiplying fractions and mixed numbers. We'll see you next time. Bye, everybody.